Hello, Algebra 2. This is Miss Marsh. So today we're going to look at graphing parabolas in focus and directrix form. Now, this is a little bit of a different form. It's the fourth form that we're going to look at. Now, you're going to want to make sure you have materials of the outlines of the notes. So the sub should be passing that around. You should get two small, about a half a sheet maybe. And then also a pen or a pencil so you can write down what I'm writing down on those. So, first things first, a parabola. A parabola is a conic section in which any point on the parabola is equidistant from a fixed point called the focus and a fixed line called the directrix. Now, we haven't actually graphed in those recently, but up till now we're actually going to see what this is. So the focus is the point that lies right in the middle of your parabola. So if you see here, I got a focus right here. This is my focus point. Notice how it's right in the middle of the parabola. And now the directrix is a line right behind the parabola that's the same distance away. So this distance right here is this distance right here. That's why you got these little tick marks here. If you remember from geometry, that meant congruent. So these two distances are the same from the vertex. So this line right here, this is your directrix. Now, the reason why our parabola is curved is because I need my points on my parabola to be the same distance away from the focus as well as the directrix. So to keep doing that, I need to have this curved shape start to appear. Now, what this is going to allow us to do is graph parabolas not only up and down, but we are also going to look at left and right facing parabolas today. So now, standard equations of a parabola with a vertex of 0, 0. Today, we're only going to look at vertex 0, 0. Later in the week, we will be looking at vertices that are not 0, 0. So today, we're only going to have a vertex of 0, 0. So we want to see there is what's known as x squared equals 4py. That is the standard form for a parabola who opens up or down. Now, to know which way it's going to open, we are going to look at this p-value, this one right here. He is the key to focus and directrix form. So if my p is positive, I'm going to open up. If my p is negative, I'm going to open down. Now, this should not be any news to you. An x squared is just like what we were just doing. So x squared is a parabola who opens up or opens down. Now, his cousin, y squared equals 4px, is opening left or right. He's a different little duck. We haven't looked at him yet. So if you ever see a y squared, you know you're going to open left or right. If you see an x squared, you're going to open up or down. Now, y squared, to know if you're going to open left or right, you are going to look at this p-value. If these p-values is positive, you're going to open to the right, which makes sense. We always think of right on the coordinate plane to be positive. If p is negative, you're going to open to the left. So if I have an opening right, my parabola is going to look something like that. If I open to the left, I need to have a parabola something like that. Now, the best thing about p is he is the number of positive or negative units from the vertex to the focus. So p allows us to find that focus, and it allows us to also find the directrix line. So we are going to want to figure out and be able to easily find that p. So I don't have this on your note sheet, so you're going to want to put this in your notebook. And by the end, you can actually put all of these notes on that note in your notebook So then these can become your notes for this section. So let's make sure we can find that p. I'm going to rewrite the standard form for this. So it was 4 times p times y. So if you notice, my x squared's the same and my y is the same. The only things that are not the same are this 4p and this negative 12 here. So I need those two to become equal to one another. I'm going to set them equal. This is going to allow me to solve for p and get that p value that I want. So to get p alone, you would divide by 4. So I'm going to get p is equal to negative 3. That is going to help me later. Let's look at the next one. I'm going to rewrite it just like I did here. I'm going to rewrite using that standard form. I have y squared equals 4px. My y squared is the same, and my x is the same. So all I need to make sure I make the same is this 4p and this 8. So let's write that together. 4p equals 8. So if I solve for p, I'm going to divide by 4, and we're going to get p equals 2, just like I wanted. Now, let's look at this last one. This last one is a little harder to get than p off the top of our head. Last few, you could have maybe done it. So let's rewrite this in the standard form. So I have 4px. So I'm going to take a look at the 6 and the 4p. The only things that aren't the same. So I have 4p equals 6. So I need to solve for p. If I divide by 4, I get p equals 6 over 4, which is the same as 3 over 2, which is 1.5. So finding that p-value is key to graphing these parabolas. So let's do this first parabola. We want to graph negative 4y equals x squared. And we're going to identify p. Which way does it open? What's the focus? What's the directrix? What's the vertex? Axis of symmetry, domain, and range. Now, notice how we're not doing increasing and decreasing interval with this one. A lot of you are probably thinking to yourself, thank goodness. So, I'm going to want to make this look like the standard form. So I'm going to rewrite it, just kind of flip-flop my equation around. Now, to find my p-value, I'm going to rewrite, just like we were doing on the last slide, and put these two equal to one another. So I have 4p equals negative 4. So if I would solve for p, I get p has to be negative 1. So I have found my p-value. Now, my vertex on today is always going to be 0, 0. So on your worksheet today, every single question you answer, you can put a vertex of 0, 0. So let us put the vertex point in there. Now I want to put a V there just so I can kind of catch it. Now, P. P is the distance the focus is from the vertex. So I had an equation with an x squared. So I know I'm going to be opening up or I'm going to be opening down. Now, since my P is negative, I know I'm going to be opening down. So what I'm going to do with this P is I'm going to move from my vertex and I'm going to move down P. So down 1. So I'm going to go from this, I'm going to put a dot right at -1 here. I'm going to label that with an F for my focus. Now, what is that ordered pair for that focus? It should be 0, -1, right? Didn't move anywhere on my x, but I moved 1 down on my y. Now, my directrix line is going to be the other way. So instead of going down this time, I'm going to go up. So my directrix line is going to be following right here. So this is my directrix right here. Now, I want directrix to be an equation. So if you remember back when we talked about lines, we talked about Hoybucks. If you remember Hoybucks, so now a horizontal line had an equation of y equals some number. A vertical line had a x equals some number. So I have a horizontal line, so I'm going to have a y equals some number. So y needs to be equal to the number it's going through, which is 1. So my directrix must be 1, a positive 1. Now, you're saying, well, Miss Marsh, we don't even have a parabola yet. So the best way to find your parabola is to find what's known as your focal width. So on your worksheet today and on these notes, you're going to want to put at the bottom focal width. Now, your focal width is your P before you even touched it. And it's always going to be a positive number. So my P, before I even found out what my P was, I had a 4. So my focal width must be 4. Now, the focal width, what's important about him, you ask? This is how wide my parabola is around the focus. So my parabola must be 4 units wide around the focus. So the focus is going to be smack dab right in the middle. So if you think about it, I need to be 4 units across from the focus. So, and my focus needs to be right in the middle. So if I think long and hard, I'm going to have to take that 4 and I'm going to have to divide it by 2, right? Because I need the F to be, or the focus to be in the middle. So I'm going to do -2 and 2. So now, with this, I can draw my parabola using that focal width. So if you look here, my focal width is 4 across. So from here to here, you should have a unit of 4. Now, your axis of symmetry is going to be just like last time. It is where I can fold this parabola and it will line up perfectly. So I know it's going to be a vertical line at x equals 0. Now today you're going to be using x equals 0 and a lot, just because we're not moving our parabola at all yet. Domain is just like last time, and domain of any parabola we said was all reals. Your range, just like last time, I have an upside down parabola, so my y must be less than 0. I have graphed the very first focus and directrix parabola for you guys. Let's take a look at the second example. Now, he is y squared equals 20x. So this should be the second example you have on your note sheet. Just like last time, we want to find P. How does it open? What's our focus? What's our directrix? What's our vertex? What's our axis of symmetry? What's our domain? And what's the range? And then, of course, make a graph. So now, if you remember, a y squared parabola is one that opens left or opens right. So I know I'm going to be opening a left or a right parabola. I want to first find that P so I know if I'm opening left or right. So I know right now I'm going to be opening left or right. And that's because of this y squared over here. Alright, so I need to rewrite this using standard form. So I have 4 times P times X. So this 20 is going to relate to this 4. So I'm going to go over here and put my equation. 4P equals 20. So if I divide by 4, I get P equals 5. So it's a positive 5. So if you look back, is my parabola going to open left? Or is it going to be opening to the right? P is positive, so I know I'm going to be opening to the right. So I'm going to have a rightwards facing parabola. Again, my vertex is always going to be 0, 0 right now. So on your worksheet, your parabola always will have a vertex of 0, 0. So let's go ahead and put him in. I have a vertex of 0, 0. So I'm going to put a V right there. Now, my P is 5. Remember, P is the distance the focus is from the vertex. So I'm going to move to the right 5. 1, 2, 3, 4, 5. This guy right here is my focus. So let's put that as an ordered pair. What ordered pair is for that focus? 5, 0 should be correct. That looks right. Now, my directrix is not to the right of my vertex, but to the left of my vertex. So I'm going to move from the vertex and go to the right 5. 1, 2, 3, 4, 5. Here is my directrix. Now, I need to write the equation of that directrix. It is a vertical line, and a vertical line has the what equation? It has a x equals, and then the number, -5. So my directrix is x equals -5. Now, just like last time, you're saying, well, Miss Marsh, we still don't have a parabola graphed. So remember, you always want to find your focal width. Now, that is the number that's in front of either A, the x, or B, the y. Whatever is in front of the lone variable, not the squared one, but the variable that's alone. So we have a 20 right now. So I know my focal width is 20. So I know around my focus, I need to have 20 units to the left and to the right together make 20. So I know I need to be 10 to the right and 10 to the left. So I know my 2 points need to be 10 away from the focus. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm 10 away from my focus right now. Now, other way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 away from my focus. Now I can draw in my parabola. This one's going to be a big guy. There we go. One more coming down. That one wasn't very good, but not too bad. Now, I have drawn my parabola in. Now, this is when the axis of symmetry, domain, and range change from last time. Just because I have a rightwards facing parabola. My axis of symmetry, if you notice, I have a axis of symmetry that's horizontal. So I'm going to have actually a y equals axis of symmetry. This is because it's a left or right facing parabola. And it's going to be y equals 0 for an axis of symmetry. Now, domain and range. I would always say domain is always all reals. That is only for upwards and downwards facing parabolas. When it's a left or a right facing parabola, my range is all reals. Now, if you look over here, I'm getting every single negative value and every single positive value of my y's. That's why my range is all reals. Now, the domain, my x's. What x's am I getting? Am I getting the negative x's with my parabola or the positive x's with my parabola? I'm getting my positive values with my x. So I know my x must be greater than or equal to 0. Notice how these two flipped-flopped. Just like on the original, we would have had all reals for domain, and y is greater than or equal to 0 for range. On a left or a right facing parabola, you are going to flip-flop your two answers around. So that is all the notes I have for you. Please try to work on your worksheet. When I get back tomorrow, I will take tons of questions. Now, make sure there's a lot of really big p-values on your worksheet today. You can make your scales to fit your needs. So if you need to make a scale of 2, 4, 6, 8 for your x's and your y scale to be 5, 10, 15, 20, by all means, make it so you can fit your parabola and the 2 points the easiest on your graph. I will take questions, so have a wonderful night and a terrific Tuesday. See you later, guys.